Hey, third graders, today we are going to continue our work with fractions, and we are going to start working with non-unit fractions, so things that have something in the numerator, the top number, other than 1. So most of the time our problems so far have been like dealing with 1/3 or 1/4 or 1/2 or 1/7. And today we're going to branch out from that and work with things like 2/3 and 3/7. And so you're going to have some work to partition shapes, right, into a certain number of units, equal parts, and then somehow marking off a non-unit fraction, so more than one section of the number of shapes you have in your whole, or number of parts you have to your whole. And then we'll do a little bit of word problem work, but most of the work is really just splitting up shapes and identifying non-unit fractions. So let's get started. I have the problem set here, so I'm going to go through that with you again. This gives you some more practice watching somebody else and going along with somebody else as they work through problems similar to the ones you're doing. So basically the directions here are to complete the number sentence. So as you can see in the first one, they've written out 2/3 in like words, unit form, and then you write out the numeric version, like 2/3, 2/3, 2/3. Then you're going to estimate to partition the shape. So you can see that they took this whole shape and they split it into thirds because the denominator is thirds, and they split it into 3 parts. And then they colored in, shaded in whatever the numerator says, which in this case is 2. So 2 out of 3 are shaded. So let's look at the next one. Go down a little bit. 3/4. So my first job is to write the fraction for that. Well, that's 3/4. And then I split this into 4 equal parts. And I'm going to shade in 3 of them. And the other part that it says to do is write the unit fraction inside of each shaded part, or each part actually. So this would be like 1/4, 1/4, 1/4, and 1/4. So that shows that there are 4 1/4ths in one whole. More on that later this week for sure. We're going to start using number bonds and things like that to explain that concept. But there are 4 1/4ths in a whole, and you're shading in 3 1/4ths or 3/4ths. Let's look at the next one, 3/7. So that's 3/7, right? And then we're going to divide our shape up here into 7 parts. We're going to draw 6 lines, 2, 3, 4, 5, 6. And each part is 1/7. And the reason for that is, like, if I just filled in this one here, that's 1/7 if I didn't fill in anything else. So each one is 1 out of 7. And then it's asking me to fill in 3, so I can fill in any 3 I'd like. I'll fill in those 3, like a random 3 for you. And then you're done with that one. The next one's 4/5. So 4 is the numerator, 5ths is the denominator, and we have to separate this into 5 equal parts, each part being 1/5 of the whole. You'll notice there are 5 1/5ths in one whole. And we're going to shade in 4 of them. So I'll shade in the first 4 here. Shaded in 4/5ths by shading in 4 sections of our whole here. And the last one says 2/6. Actually, it's easier if I do this. And I need to shade in 2/6. So I'll shade in the first one and the last one, and I shaded in 2 out of 6 of the different of the whole. Here we go with the word problem. Mr. Stevens bought 8 liters of soda for his party. His guest drank 1 liter. What fraction of the soda did his guest drink, and what fraction was left? So he bought 8 liters. That's our denominator. 8ths is our denominator. That's the amount. That's the total amount, right? The whole amount of soda that he had is 8 liters. So 8 liters. And the people drank 1 liter. So they drank 1/8 of what he actually bought. Sounds like he needs to plan better because he bought way too much. Right? And so I could draw that like 2, 3, 4, 6, 7, 8. So here's 8 parts. Like you could think of each of these as like a bottle of soda, right? We've just put them all on a line here, but there's 8 bottles of soda, and his guest drank one of the bottles. So they drank 1/8. Now we can think for part 2, it says what fraction was left over. Well, here's the real tricky part. Here's the thing that third graders usually struggle with. The denominator is still 8 because the whole amount that he had was 8 at the beginning. So we can't change that. Even though one got used or consumed, we still think of it as 8 making up a total, sorry, a whole. So what's left over is 7 out of 8, or 7/8. There's 7 containers that didn't get used out of 8, which was the beginning number. So the beginning number. And that's true here too. What I want you to avoid is, what a lot of people do is make this 7, right? They'll change that to a 7 and they'll say, well, there's only 7 left. So now the total is 7. But you have to think of it like, what was the total at the beginning? Before anything happened, what was the total then? And that's how you have to approach these sort of problems. That's something that we're going to keep going over because that's the thing that I know that third graders find challenging. All right, we're just going to do a couple of these because this is something similar to what we've done before. We did it with unit fractions, and now we are doing it with non-unit fractions. So fractions that do not have 1 in the denominator. I mean, in the numerator, I'm sorry. So the first thing is find out how many equal parts there are. Well, this has 4, 5, 6, 7, 8, 9. So there's 9 equal parts. 1, 2, 3, 4, 5 of them are shaded. The unit fraction, it just wants us to show that we are working with ninths. So this is like, what's each box? What is 1 part of the whole? So 1 part of the whole is 1/9. Like this is 1/9, that's 1/9, that's 1/9, that's 1/9. Over here, it wants to say all of the shaded ones added up. What fraction is that, or what part of the whole is that? Well, in this case, there's 5 of them, and there's a total of 9, so 5/9. Let's skip B and we'll go down to C. We'll do every other one here. So in part C, we have 1, 2, 3, 4, 5, a total of 5. So I automatically know my denominator is going to be 5. 4 of them are shaded in, and that's what it wants to know in this box. The unit fraction is just asking, what's any one of these? Any random one that I pick represents 1/5 of the whole. And then the last part says, if I take all of my shaded ones together, what fraction is that? Well, that fraction is 4 shaded ones out of a possible 5. And then the last one here, getting into some important stuff that we're going to cover later this week, is there are 8 parts, 8 are shaded. Each part represents 1/8. Like that's 1/8, that's 1/8, that's 1/8. They're all 1/8. And the total is 8/8. Now, when you have 8/8 shaded in, that means you've filled in the whole thing. Anytime you see a numerator and a denominator matching, if they're the same number, that means you have 1 whole. So 2 seconds, 2 halves, 3/3, 4/4, all of those are representations of 1 whole. So that's just something that we're going to continue talking about that this week. What fractions that add up to 1 whole. We're also going to talk about fractions greater than 1 whole. So this problem right here is a good transition into the work that we're going to do later on in this unit. All right, I am going to let you go for today. I'll let you go do your independent practice. This is, again, similar to work we've done. We've talked about non-unit fractions a little bit before. Now you're just getting a little bit more experience using them on your own, doing them independently. So please let me know if you have any questions. Otherwise, I will see you back here tomorrow for our next lesson.